Hello, Algebra. Happy Monday. I'm sorry to bring you your instruction this way, but this is what we have to work with. So at least we have modern technology that I can come to you through the modern wonders of the Explain Everything app. So here we have notes on what a scatter plot is. This shows the relationship between two variables. I expect you to write this down, please. Shows the relationship between two variables. So there are three basic types of relationships. There's positive. I'm writing it this way on purpose. So basically, if you have a positive correlation, you have data that is increasing with X and your Y is increasing. Y increases with X. And it basically looks like a line that's going up and to the right. But each of these data points are in a ballpark, and the line that would exist would kind of be the average of all those dots. When they're tight like this, it's considered a strong positive correlation. Now her notes, the lady that created this, she actually doesn't do what I'm doing, but you need to, especially for your test, you have to understand the difference between strong and weak. And really, it's pretty obvious. A weak correlation still goes up and to the right, but the dots are, in general, further spread out. So this would be kind of like a weak, but still positive correlation. Here, the first one's very strong and tight to the center. If you were to average it, you would see they're almost touching that line. But here, if you were to average it, the data is pretty spread out. And so this is a weak correlation, but it's positive still because it's going up and to the right, whereas the first one's strong. The next one, negative, you can probably predict, will go down and to the right. So if it's a strong negative, it's information that is pretty tight to what the average would be. This would be strong negative correlation. So as X is increasing, the Y data is decreasing. And then a weak negative is that the information is much more spread out, but it's still going down. There's still nothing in that bottom left quadrant closer to the origin, and there's still nothing above in the upper right section. It's still a pretty clear negative decrease of Y values as X increases. So the difference is that once you get here to the none, that's when you see it's not strong or weak. It's just that the data is all over the place and there's no obvious linear association, whether up, positive, or negative. There's no line average that could be drawn in either direction. This is just no association. Okay, so the line of best fit is kind of what I've drawn in my solid lines. This would be considered your line of best fit here. And this here would be considered your line of best fit. Basically, it's the solid lines within the correlated data. It's kind of your average, your guess. It's the line that best fits that situation. So given a positive or negative correlation, it's the prediction. It's possible to write a prediction equation. Okay, so given a positive or negative correlation, notice this doesn't work for the none, but it's still possible to write a prediction equation. And we're going to need our graphing calculators to do so. So, an example, the data in the graph below shows the resting heart rates and ages of a group of 20 people at the gym. So you could probably predict as the person gets older, their resting heart rate is a little higher. Is that true? No, I guess it's slower. I guess as you get older, your heart rate gets slower. That would make sense. A young person would their heart would beat faster. So then, which line best represents the data? Graph each line just to justify your answer. So we can say this is a strong negative correlation. You can see that the data is kind of going downwards to the right. And it's very tight towards what I would say we could predict is the center. So let's just graph the 4 lines and then see what we come up with. So here, if we were to start at plus 80 and go down to over 3, well, that hits that one. Down to over 3, looking less likely. Down to over 3, down to over 3. Yeah, that doesn't look so promising. The data doesn't really follow that line, does it? So that's probably not a good choice. How about the next one? Starting at plus 75, going down 1 over 3. Okay, same one as before. Let's see, I'll change color here. Down 1 over 3, looking good. Down 1 over 3, down 1 over 3. Possible candidate, maybe. There is a much more scientific way to determine this that you will see soon. But for now, with this is a possible candidate. How about line C? Start at plus 80 and go down 1 over 3. 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 And how does that look? Doesn't really hit through the center of the data, so I'd say that's a big nope. All right, how about line D, y equals 50? So what we're saying is no matter what x is, y is 50. Well, that misses altogether. So which one of these would you say is the best choice? Would be line B. Okay, it's the one that goes through the most center of the data. So let's go down here. They ask you to determine which line best fits the data shown on the graph. Again, you're going to do just like we did and graph all 4 and find the one that best fits.